I'm Virgil with Building Integrity.
And I'm Tony with Chapman Heating and Cooling.
We're here today. We just finished up a blower door test in this small 400 square foot cabin we're building south of Columbia, Missouri. And Tony, just want to ask you, what do you think of the results, and what do you think what we're doing here?
This is really cool, really impressive. Straw bale, straw house is something I've always been interested in for, I shouldn't say always, but for at least the past 20 years or so. And I jumped to the opportunity to come out here and just see this being built. So really neat design and product.
So just a question about the blower door test. Maybe some people wouldn't know what that measures and what we're talking about when we say that. Do you want to explain a little bit of the mechanics of what we just tested and what results we got?
Yeah, so basically, I do this throughout Boone County, probably 10 to 15 a week. And what we're doing is we're depressurizing the house to negative 50 Pascal, just to see basically a number how leaky the house is. And the phrase uses air changes an hour at 50, so ACH 50. And typically in Boone County, I'm seeing houses somewhere in the range of 5 to 7 ACH 50. Today we saw, what was it, 1.2 something, 1.25, I believe, ACH 50, which is incredibly tight. It's pretty exciting to see.
So we're talking about like the entire volume, how many times per hour at 50 pascals of pressure of a vacuum, how many times does the volume of the house pass through this little hole?
Exactly.
And it's 1.25.
Yeah, it's very tight.
Here. Pretty tight.
And what they say that ACH 50, the negative pressure of 50, they say that's equivalent to a 20 mile an hour wind hitting the house.
Very cool. So. Thank you for being here and helping us.
Yeah, no, it's exciting.
Real concrete measure of how we're doing.
Exciting to actually get to use because typically on a house I'm doing, it's either the open fan or the A ring. Occasionally it's the B ring. Today we got to use the C and the D ring, which is exciting.
That would be the smallest option opening. For pulling air through. Yeah. Very cool. And would you, something I've heard is the smaller your house, the harder it is to score well on these things, right?
That's very true.
What are those, like what's that look like? And
so yeah, this being a small house, but still getting that tight is incredible because with all homes, you have to have, X number of holes in the house. A larger home is, the number of holes doesn't always equate to the size. They can just pad their numbers by increasing their volume with the same number of holes or very similar number of holes. Whereas this is a very tight, small house with, normal number of holes, but incredibly tight, which is great. So the city of Columbia, if it's under 10 ACH 50, they don't require me to make recommendations on air sealing. Now, 10 ACH 50 is pretty leaky. The average is somewhere probably around 7 ACH 50. So somewhere between 5 and 7 is what I typically see. If I go into a house, it's down around 3 ACH 50. I'm like, your house is very tight. Don't do air sealing unless you're ever bringing in fresh air.
So we're getting double.
We're getting
double that performance.
We're getting way down. We're getting down to under
a third of that performance.
Yeah. Adrian, what are you doing?
So we found a leak around these staples. So I'm just taping it up while I have the opportunity to do it. And it's my understanding that the Intello manufacturer says that a staple that's been left in does not necessarily have to be taped over. So that's been kind of the practice on this project. But we are noticing some leakage around like groups of staples or staples that might be associated with like a fish mouth or little wrinkles in the Intello wrap.
Yeah.
Oh, I can see.
So right here we have the tape is peeled off the windowsill and just left like not even a 16th inch, a little bit, a couple millimeters right there. And then when there's smoke in front of that, you can see the air being pulled through that little crack.
Yeah, that's awesome.
Oh, that's fun.
That's awesome. Let's
tape that up.
So I think we could seal around the edge of that just a bit.
Personally, I really like this detail around can lights. You just have the electric coming in through this wooden box, and then that wooden box is sealed to the rest of the air barrier.
So we're just looking for thermal leaks and bridging, and you can see the thermal bridge where the roof and the walls meet, showing up as the blue on the thermal camera.
Mm-hmm.
All right, slide it in.
So this is the Lunos E squared. Is that right? Or is it
That
an
is the
ego?
Lunos E squared.
Okay,
Yeah.
the Lunos E squared is our energy recovery ventilator. There is one penetration that has this motor fan on one side of the house, and then there's another penetration on the other side of the house. So because this house is so small, we were able to use just one pair of the Lunos. And the way it works is that fresh air is brought in through one side of the house, and stale air is exhausted out of the other side. And so in the wintertime, that exhaust heat is going out of the house, but it is retained through a ceramic core inside the energy recovery ventilator. And then every 4 minutes, I think, the change of airflow switches. And so then the pipe that was exhausting the stale air is then pulling in the fresh air. And so then that fresh air is heated by the heat that was recovered through the ceramic core and the technology inside of the pipe. So this is a way to provide mechanical fresh air that's also filtered and without losing all of the investment in the conditioned, the cooling or heating that happened for the interior air. So it's really exciting to show you a little bit about the project at this stage in its construction, because the straw panels have been installed and really all of the air tightness details have been managed at this point. We have an interior vapor permeable air tightness barrier that I'll let Virgil explain more about the product itself and then how we are dealing with different material transitions to maintain air tightness.
Thank you. So what we're looking at here is the ProClima 3-part air detailing system. So we have the actual membrane, which is the Intello Plus, and they call this like a vapor intelligent or a smart membrane. Essentially, the permeability or the vapor resistivity changes based on where the humidity is at relative to the membrane. So when it's cold, and it's also temperature related, right? So when it's cold outside, but hot inside or warm inside, you can expect that warm air to want to condense on the cold surface. And so the membrane actually tightens up and is not as permeable. It gets tighter. It turns into more of a vapor barrier and doesn't let condensation or moisture into the wall system. And whenever so that would be like a wintertime case. In the summer, if it's hot and humid outside, typically what you have is like the hot air comes in and condenses on the cooler surface, which would be like, the inside finished surface of the house. In this case, this opens up, the vapor permeability increases, and so actually that moisture can kind of pass through, the vapor can pass through this membrane. So you don't deal with the issues of like mold and condensation just settling into the structure, into the wall system itself. That's a long-winded take on it. But Intello Plus Tescon Vana is a tape that goes with the Intello, again, made by ProClima. And the other part of this would be the Contiga HF. It's an air sealing sealant, airtight adhesive. It never quite dries out. It remains sticky and tacky, so it keeps a good air seal. In this case, we used it to seal the Intello to the slab. And we should have cleaned that up first. But yeah, you can see that it's still sticky under there. It's holding the Intello down to the slab to keep a continuous air barrier from the slab over here all the way over across the whole ceiling and all the walls to the slab over there, all around the whole structure. And past that, we have these penetrations for our HRV system. This is, in this case, the Lunos squared. But we use, again, part of the ProClima system is the Rowflex gaskets, which we've already air detailed here, so you can't see the full shape of it, but it's basically a rubber gasket. It's a rectangular shape. It goes around the whole opening and is fitted to be snug and grab the pipe of whatever is going through the wall, which then we taped just for extra good measure. So we can be sure there's no air leakage around these penetrations.
Mechanical ventilation or fresh air is important, of course, for human occupants, but also to prevent mold growth. Stale air that remains, humid stale air can create perfect environment for mold growth, inside the building, not necessarily worrying about mold growth inside the wall cavity, although that's possible with poor detailing. But the energy recovery ventilator really helps prevent mold growth inside the interior envelope of the building.